FRQ 2007 number 1 by Maggie Tran. So number 1, let R be the region in the first and second quadrants bounded above by the graph of y equals 20 over 1 plus x squared and below the horizontal line y equals 2. So as we know before, our equations are y equals 20 over 1 plus x squared and y equals 2. So if you plug this into your calculator, the graphing section, we have 20 over 1 plus x squared, but we have to be sure to put the parentheses or it will come out wrong. And so as you can see, our bounded region is right there. It's above y equals 2 and below 20 over 1 plus x squared. And that's our region R. So problem A, find the area of R. So what we're going to start off by doing is find the point of intersections of where the area is bounded. So we're going to set the two equations equal to each other and solve for x. And if you solve for x, you get x equals plus or minus 3. Or we could have just used our graphing calculator and look at the graph and see where the 2 point of intersections are. Like we could have just traced the graph. So now that we know our point of intersections, that's going to give us our limits for our integral. So we have a equals integral from negative 3 to 3 of 20 over 1 plus x squared minus 2 dx. A common mistake that people will make is that they incorrectly identify the top and bottom function. So now, to put this into our calculator, we're going to use the integral button, and we're going to do negative 3 to 3 of 20 over 1 plus x squared minus 2 dx. It is important to correctly put the parentheses where it's needed so we can get the correct answer. And if you solve this out, you get 37.96, and that is our area. So problem B, find the volume of the solid generated when R is rotated about the x-axis. So for this one, we're going to use the same region R, and this time we're going to rotate it about the x-axis using circles, so we're going to use the washer function. So we're going to have v equals pi from integral from negative 3 to 3 of 20 over 1 plus x squared minus 2 squared dx. So we're going to plug it into our calculator, and we have the integral button, and we're going to have negative 3 to 3 of 20 over 1 plus x squared minus 2 squared dx. And we have to be sure to put in the parentheses correctly or our answer could come out differently. Then we get 595.62, but that's not our final answer because we still have to multiply by pi. So our final answer is v equals 1,871.19, and that's our volume. Common mistakes for this problem is that when we plug the integral into the calculator, we put the parentheses in the wrong place, and therefore we get a different answer. Also, we forget to multiply by pi in the very end, thus giving us a wrong answer. So problem C, the region R is the base of a solid. For this solid, the cross-sections are perpendicular to the x-axis are semicircles. Find the volume. So basically this problem is finding the volume of semicircle cross-sections. So we're going to use v equals pi over 8 s squared. And the pi over 8 is the constant of proportionality for semicircles. So our equation comes out to be v equals pi over 8 integral from negative 3 to 3 of 20 over 1 plus x squared minus 2 squared dx. So now if we grab our graphing calculator and use the integral button, and we plug in the equation, integral from negative 3 to 3 of 20 over 1 plus x squared minus 2 squared, and we have to correctly put the parentheses in and square the whole thing. And then we have of dx. Then we get 443.77, and then multiply that by pi over 8, and our final answer is 174.27. A mistake that I made the first time around doing this problem is that I used the washer function, so I squared 20 over 1 plus x squared and squared 2, but you're supposed to square only s, which is just 20 over 1 plus x squared minus 2. Some overall common mistakes we should look out for when solving these AP problems are that we use the wrong function for when solving the area or volume of something. For example, we confuse the disk function, washer, or shifted washer function. Another one is that we incorrectly identify the top and bottom function, which could affect our answer. And then another one is that we forget the constant of proportionalities for when solving the cross-section problems, so it's important to memorize the constant of proportionalities. Another one that I like to add is that we forget to input some parentheses into the graphing calculator when solving for integrals. Thanks for watching. I hope you enjoyed the video.